please welcome Cheuk Ting Ho, who will talk about Memray.
Hello. Hello, thank you for sitting here before like the clock is on time, but it's fine. So for people who come in late, it's fine. You're also welcome to come here. You didn't miss anything yet. Hello, so I'm Cheuk, and this is probably, I always say, the most important slides of the presentation, because you get the link to the whole slide deck, so you don't have to take any other pictures if you got this slide. Also, there's like my contact information there. For example, my Twitter. Oh, I'm also on Mastodon, but it is like same handle. You'll be able to find me with the same handle. So if you are like, Mastodon person, you can also find me. Also, I am on. Well, I guess you won't use GitHub to message me, but like you can also find all of my social media things like on my website as well. So yeah, so Memray and profiling data science work. So I guess you're here because you care about memories when you run the code. So before we start, I'll just quickly introduce myself again. So I'm Cheuk. I am working in Anaconda. And we have a booth outside, so come and chat to us. We have stickers, we have nice swag, so please come. And also, I love open source project. I always said that I'm not just a developer advocate, I'm also open source advocate. I love, I got involved in different open source projects in the past. I'm a contributor to different projects as well. I also organize a lot of community events for the community. I, organized PyData London, which is happening less than a month. So I hope you were there at the lightning talk when I introduced it. Also, there will be another one, EuroPython, that's happening in July. And also organized like various, I haven't updated the logo. So like these are the conferences that I organized in the past, but I'll be organizing more. So yeah, so if you kind of need a recommendation of which conference to go to next, so come talk to me. So question for you. Have you seen the Mamray era before, or are you so blessed that you have never seen this era? Who have seen this era? Yes, mostly all of you. Okay, good. So yeah, we all have this problem, Mamray era. When we see it, it's kind of like part of ourselves died a little bit. It's like, oh my God, I have to run the whole thing again, right? You restart a kernel if you're using the notebook, and then I have to run all the like 50 cells above it, so which is not the fun stuff. So maybe we should think about doing memory profiling. So what is memory profiling? What are you talking about, Cheuk? Like, what are you doing here? So I guess for those of you who may be kind of new to these kind of like, computer science, lingo, and these terms, I'll just give you the background information so everybody's on the same page. Profiling in software engineering or computer science is actually investigating a software's behavior. So it's like investigating your code. So for example, you have some code, you run it on a Jupyter notebook, that's also, we consider it a software. It's like some code that's running. So in this presentation, it's the software. So when it's being executed, for example, you run the cell, then something's happening, right? So at that time, we are kind of trying to see what's going on in your code. So these kind of in inspection, we are calling it dynamic analysis. So the opposite of it, of course, is static analysis. But what is static analysis? Well, static analysis, for example, if you have reformat your code, for example, with black or something that like the tool that kind of make your code look nicer. So within that tool, it will do some static analysis, which is just look at your code as if it's a text file. So it doesn't execute your code. So on contrast, when you do profiling, it's doing dynamic analysis, which is we are inspecting the code while it's running. So it must be a code. It can't be a text file. So, of course, we need a tool to do that. And the tool that is doing it is called a profiler. So, but we are talking about memory thing, right? So it's the memory profiling. So just like the name suggested, memory profiling is a profiling process, but specifically like talking about memory. Not talking about whether the code is fast, not talking about other things, but how the memory is being allocated and used when your code is running. And also, a lot of times, when we talk about memory allocation, we will talk about another thing, which is called garbage collection. So garbage collection is, well, the name may suggest a little bit, but why do I have garbage in my computer, right? So it's basically what it means is that when you have some, so you allocate memory to store something. So, but when this thing is not needed anymore, right? You want to free up the memory for other object or other things to use. So you have to free up that space. So that process is called garbage collection because, we're not wasting them. Actually, I found it should not be called garbage collection. It should be like garbage recycling or something like that. I don't know. So we're recycling the memory and free it so other process can use it. So, yeah, so when we are kind of like observing how the memory is being allocated and all these like memory being free up, so all these being observed when the program is executing, that's the memory profiling. So why do we talk about that? Why am I sitting and listening to you talking about these jargon things that like memory and all stuff? So I hope you're doing some kind of data science work or some kind of heavy, like kind of mathematic. Maybe you're a researcher, you're dealing with a lot of mathematical calculation, or you are a data scientist, you are kind of, handling a huge amount of data a lot of times. So this is actually useful for you because data science work or kind of numerical research work involves a lot of data. It kind of is not a very lightweight job a lot of times, kind of, when you have a huge data set, you need more memory, so it's quite heavy. But the thing is, like Python apps actually are not very good at memory management compared to maybe other things. So a lot of times, actually, you see memory error. That, is Python being very nice and see that there's a problem with memory and tell you, oh, there's an error. But sometimes it's actually even worse that I remember when years ago when I was a not so experienced data scientist, a lot of times when I run some Jupyter notebook that had some like kind of huge data frame, pandas data frame, and it would take a long time to run, and I don't know whether it would finish. It would just like never finish. So yeah, it would just hang on to something, right? As something is going on, I don't know what's going on, So we need to know what's going on. We need to find out if there's a problem with memory or some memory are leaking or your code is not optimized, it's wasting resources. We need to figure that out. So you won't have these like hang on forever kind of scenario. Or I used to have a colleague who is just like, oh, not enough memory. Spin up a huge, like a bigger cluster on the cloud surface. Yeah, it's not very efficient in money, right? So not good. So before we actually dive into the tool and see how things work and how it can help you, again, like a lot of things that we talk about, we want to make sure that when we are communicating these technical terms with technical people, that we are not mixing all these concepts up. So we also cover a little bit how, like, what are the different memories and how, like, how Python deal with them. So first of all, there's this, you may see some discussion with these terms on Stack Overflow or things like that. It's like heap memory and stack memory. So what are they? Heap memory, so it's basically, usually it means that it's like, it's used to store global variables. So a lot of time you hear that, oh, it's got like some variables stored in the heap. So that's what it means. It's the heap memory. And so the difference between the heap and the stack has an order of things, but heap is basically just, it could be anywhere. It's just like a space, it's like an empty room. You can put down things anywhere. You don't have to be organized. And so the trade-off of not being organized is you have to have a reference. You have to know where to find the stuff that you put it in the room. Otherwise, you will lose it, which is memory leak, which is not a good thing. So we need to, have a reference to them so you can free them when you are no longer needing them. And then, or, which is like, if you unfortunately have some memory leak and stuff, when your process terminates, then your OS will take over and, everything got destroyed, so it will be free. But with a lot of time, we don't want it to be like that, right? We want to be efficiently using the memory. So on the contrast is the stack. So stack is used to store local variables. Things are more in order. because, when we kind of, remember when you were a beginner or you're teaching someone who's a beginner, right? It's like local variable, we can't see them outside of the function or something like that. It's because everything is stored in order. So, when it got free, when you execute, return at the function, so it's a local variable, so you can actually delete it because it's stored in order, so you can basically go trace back your steps because everything is aligned. You can just trace back and delete them. So, you don't need a reference. So that's less prone to memory leak because you won't lose the reference if you don't use a reference, right? So, okay. Another thing that got talked about a lot of times are the residence set and the virtual memory. So I think you have heard the term virtual memory a lot more than residence set. So residence set is actually the actual memory, which is like physical actual memory on your RAM. So for example, when you buy a computer, it says how much RAM is in it, so that's your residence set, right? But it's a lot of times, because now modern technology, it doesn't mean that you can't run a process that use more RAM than your physical, residence set. That is because some processors are very smart. Your OS is very smart. They will swap out the memory because, I'm not using it yet, so I'll swap to something that I'm, using. So that's why we have the term virtual memory. Virtual memory is actually what your process think, the memory that you have. It doesn't care that you have actually swapped things to put everything inside your residence set. It's just how much has been used. So because of this magic, so usually the residence set can be smaller than the virtual memory. So you can run something that require, let's say, 10 gigabyte of RAM in an 8 gigabyte of RAM machine because things got swapped. So that's the difference between residence and a virtual memory. So yeah, a lot of times we kind of have to look at the residence memory, like whether it has been filled up full, then you have a problem. So, but this is just general terms, right? Like I'm not talking about specific OS. And because different operation systems works differently, things can be quite tricky when we talk about memory profiling. And that would lead to something that I would cover later, that, why. But just bear in mind that the different operation system can be very different. So, but Python, try to be running on different operation systems. So Python will have its own way of handling memories to make the implementation a little bit easier. So it will work on different type of operation system and different machines. So Python, what it does is that it will do something that is like quite smart, but it could be good for some scenario, but maybe sometimes not good in some scenarios. So what Python does is that all the Python objects and data structures are actually kept in this like private heap, and it got its own memory manager. Wow, very abstract construct, right? So what does this mean? So maybe you have heard of PyMellLog. So PyMellLog is the memory manager that Python uses. It's not the only one. There's also different manager that like talk to your virtual machine manager and all that stuff. But PyMellLog got talked a lot because it's kind of Python specific. So what it does is that actually it will have a kind of assign all these like small Python objects to fill up this heap that is keeping. So what does it mean? So what it means is that it's only applied for small objects though. It's like only 512 bytes of memory. They are considered small. So any object bigger than that, it doesn't apply for them. So there's like all these private heaps that PyMellLog uses. It's called Arena. So they have also the fixed size. So imagine you are stacking all this block, like shoe boxes. You try to fit all these shoe boxes in this room. So that's a good thing about it because it's very efficient. Everything needs to be a multiple of 8. So it goes from 8 to 512. If it's bigger than that, it's too big. The shoes are too big. We won't store it here. So imagine like you have small boxes and big boxes. They all kind of, they will all fit together very well because they are a multiple. So it's very efficient for small objects. But then, of course, you can argue that it's like, well, it's not squeezing all the space available, you're wasting some space, but that's how Python deals with things. And because they're all small, so they're not wasting too much space either. So, but if it's bigger, Python got other things that could handle it, so don't worry about it. Python can still handle big objects. And because Python is so different and do all this shoebox stacking kind of thing, that's why a lot of tools, memory profiling tool, doesn't work well with Python because it doesn't understand Python is doing all these things. So there's actually a tool that I found actually work with Jupyter, and so it's nice. But the only problem is that there's no Windows support yet. I've met some of the maintainers in another conference, and then I asked oh, but there's no Windows support, will you support them? And they said that if someone is up for maintaining that part of the code, then they would be like, okay, let's talk, but I can't maintain it. I don't understand how Windows works, so if you're a Windows expert, if you want to maintain that, let me know. So the tool is called Mamray. Let's see how it works. So let's have a look. Oh, sorry, you're seeing all this messy stuff that you're not supposed to see. 1 second. We have this problem. I have the same problem yesterday. Okay, so I have some Jupyter notebook, of course, and this one is actually all the example that I get from the Memray documentation. So these are all the basic stuff that I think is quite useful to learn, because when you are actually using Memray, a lot of times you are spending the time looking at the frame graph. So what is a frame graph? Well, you will see it in a few seconds. So first of all, when you use Memray, you would have to load it in, right? So you load this Jupyter extension. Memray here is just like a very simple one. It's just inline and stuff. Use the percentage magic that we all know and love. And then it will generate a frame graph for you. So actually also this, you can add other options. Again, what options you can do, you can also check out their documentation. And you see here, this is a very simple example. There's two functions doing the same thing, printing a lot of A's. And then, A and B A is just calling B, so it's just like a parent. And then B is calling C and D. So you can see this is the very, very basic frame graph that is generated. And you can see that, whoa, what's going on here is because C and D are doing the same thing, so they are the same size. So you see that actually the width here is actually the memory that they are using. So because they're doing the same thing, of course they're using the same amount of memory and same size. But because this is the B, so B is calling C and D, so it's actually their parent. So when that is the parent, so it's sitting on top of it. Or if you don't like it, right, you can actually flip it over and look at it like this. So the parents will be sitting below them. And then because of A is calling B, so it will sit below as well. So this is basically the main function is calling A. So this is what it is. So now, let's look at a more meaningful example, because this isn't much, right? Just a bunch of boxes. So let's look at this one and found interesting things within it. And so now we have a more interesting graph. So things are a little bit more irregular. And to interpret this, again, I want to flip it over. It's just that it works better when I'm explaining things. But, you can do it either way around. It doesn't matter. So here, there's a concept that I want to talk about here. And also why I flip it around is the roof. So, for example, this one. This is a box. And it got one roof, right? This is the roof. It's quite long compared to other things. So this is another box. It also got a roof. This roof is smaller than the other one. Probably, if you guess, this is using less memory, right? Because it's shorter. And this is, bigger. So this is, so if you look at the number, it actually, sorry, it's because I assume you can't really see the number, but trust me, this is using more because it's 2 times. So that's that. Another funny thing, so you can talk about this, right? So does this box has a roof? It doesn't, because there's another roof, another box sitting on top of it. So it doesn't have a roof. So well, there's nothing that you can see the sky here. So this doesn't have a roof. So the reason being, because this is just calling this function, so it doesn't use extra memory, so that's why it doesn't have a roof. So every roof actually means that there's some memory being used. So the interesting bit is this one. This one here, sitting here, can I click on it? Oh, okay, I can click on it and focus on it, but that's not what I want. So let me restart and regenerate it. Okay, so let's flip it again. Okay, so this one is interesting because this one has two child. So it got this one and got this one. So it got two child and a roof itself. So by itself, it also used some memory. Of course, it used memory while the children is using memory, so it used memory, but at the same time, it's also used memory that is not because of the children, right? So because this is the roof. So, for example, if you look at this, you can think of where you can optimize it, right? So, if these process, all these are already, you have inspected these 3 boxes and they are already, what is supposed to be, then this is very suspicious because like, oh, maybe I can optimize it a little bit so to reduce the roof on that side. But this one, because it doesn't have a roof, so you already know that you should not look at it, right? You should look at the child to see if you can optimize there. So every time if you suspect a leak or try to see if you can optimize things, look for the roof. That's where you should start investigating. So that's the number 1 rule of trying to interpret a frame graph. There's also another small catch is that, for example, missing is missing. That's why it's called missing, because you can't find any boxes that is corresponding to missing here. And reason being is missing is because by the time these got returned, missing is not holding any memory. So that's why it doesn't contribute to the frame graph. So again, you don't have to investigate if it's not there. So you try to start investigating when there's something that has a roof. Then you investigate this process. This is very simple, right? It's just A, B, C, D, very textbook example. What about something that looks more real? Okay, let's look at something that's more real. So this is my ice cream project. So this is a very it's more realistic, but still something very simplified. It's like 2 CSV about ice cream. And I'm trying to do some data manipulation and join them together and things like that. So let's look at how we can profile them. So I'm using pandas here. Pandas is a very huge and complicated library, but it's very useful. So I'm using it. So you can see that I read the CSV, it become a pandas data frame here. These are all the reviews of certain ice cream. There's a product, it's all the information about different ice creams. And so what I want to do is to get a statistic year on year. So just different years will have a separate statistic because all these reviews are across 5 years or so. So I will run them. So you see that I have 2 here. So the 2 of them are different because I'm doing something different here. One of them I'm being smart. I'm just going to truncate the date because date. Can I find it? OK. The date is actually a string here. So if I want to get a year, I just truncate and take the first 4 characters, right? Because all of them are same format. Very easy. But the other way, I kind of doing it properly, try to convert them into a datetime object and find the year and things. So 2 different ways of doing the same thing. And then now I want to see the performance. So this is why I join, do some aggregation, and then join the data frames together. And I'm going to inspect them. So this is the first one that I'm using the smart method. So let's see the graph. And wow, there's a lot of things because, again, Pandas is a very complicated library. So that's why it's like got so many stacks. But what we can see is to see what we have done. So we are using this using the get year stack. So get year stack is here, and I can't really see. So another thing, if you are like this, right? So I can't see how many memory is being used because it's too long. What I can do is to find the HTML file. So it's like tm, pm, something. OK. So let's find that file. So it's here. It's saved as the result. So it's this one. So you open it, you'll see that, oh, now it's an HTML file. So you can see, you can zoom out and then you can see more. So this is easier to see if you prefer HTML file. And let's see, get used to that. So this one is using 4.6 megabyte. So yeah, so we have the number, we can compare. And let's go back here, and then, whoa. And then let's do the second method, to do the proper method, to see which one is more efficient in terms of memory. So this one, I'm using the version 2. And again, I can't see a thing. So what I'm going to do, I'm going to pull that out as well. So it's something by. So let's see if I can find it. Right. This one. So number 2 is 4.5. So what's the other one? I can't have memory. Oh, actually, the other one, the smart method is like using more memory at this time. But actually, they are not that different. The funny thing is, like, every time is a little bit different. So I guess they are not really, like, they may be just like small errors because of different runs and stuff. But you can actually look at it and compare and see what's actually doing underneath. So in this case, you see that these two are actually not that different. And actually, this one, doing it properly, actually use less memory for some reason. This run, so yeah. But you can see the graph is totally different because I'm doing different process. And if you really see what you can optimize, what you can, again, look at the roof. You can see, wow, all this stuff. But then, like, this is pandas internal, so you probably you can't really do much optimization unless you avoid that process. So you maybe use another pandas function to do things and stuff to avoid that. But so yeah, so that's basically what it would look like if you use it in real scenario. And again, to optimize it, you have to do some investigation, kind of like Sherlock Holmes. You have to look at which one got the biggest roof and see, like, oh, why Panda is calling that, or maybe I can avoid that by using another pandas method. So, but you have to experiment and try and investigate. That's all we do a lot of times. So that's Mamray, and I think before the Q&A time, I would give a service announcement for EuroPython. So that is the conference, European supposed to be biggest conference in Prague this year in July 17th to 23rd. There will be tutorial and then conference day and then sprint. So yeah, or you can join remote if you don't want to go to Prague. But I don't know why you don't want to go to Prague. It's going to be summer. It's going to be nice, and it's a beautiful city. So yeah, if you want to know more about EuroPython, come talk to me. And also, if you have questions about Memray, you can ask now or when I'm outside. So thank you so much.
Thank you. Are there any questions? Yes.
Can I use it in a library that I wrote in, let's say, VS Code and call it from Jupyter to profile my VS Code code? Not
VS
my
Code.
Jupyter code.
So let me repeat the question for the technical reason and also make sure I get the question. So the question about like whether you can use Memray with VS Code, right?
Yes, but ideally I would want to display the result in Jupyter, but I import a library that's written somewhere else and I profile that.
Yeah, so you want to display the result in Jupyter Notebook, but you are profiling the code in VS Code.
Correct.
Right. So I would say that because when you do Memray without Jupyter Notebook, it will also generate the HTML file. So it's exactly the same thing that you see here. So I don't know whether that would already suit your use case if you have an HTML file that looks like this. But if you want to put it in Jupyter Notebook, then you just have to put this HTML result in the Jupyter Notebook. But that's another thing. You have to write some code, but that can be done. Yeah.
Thank you.
Hi, thanks for introducing us to Memray. So if you do get a memory error, is it too late to, or if you get a memory error while you're invoking your profiling and your flame graph, are you out of luck, or how do you deal with that situation?
So when you get a memory error, is it too late to look at the frame graph and solve the problem? So I think that's more, I think that question you ask in mind maybe because like it's about the Jupyter notebook when you're using it. Because like if you are running a Python code, if you got a memory error, of course you would run it again next time and maybe do some inspection with Memray. But with Jupyter Notebook, I think when you get the memory error, so that process is already stopped. So I would suggest you put in the Memray extension, run, restart the kernel and run the whole thing again. That's what I would recommend you do. But technically, can you just like, hold on to the kernel and then just like run the same code again to inspect it? I think you can, but I won't recommend that because, then the state of like what your kernel is a bit of a mystery at this point. So I won't recommend that. Yeah.
And I think we have one last question.
Yes, thank you for the presentation. Do you know if this package is working with Python packages that are calling C++ code?
That's a very good question.
And second question, do you
yes.
know any extension that I can set the limit of RAM memory that will be used by the kernel? Because when you have a memory crash, it's too late. So, can I set the threshold for maximum RAM memory that will be used by my code?
So first question, let's do it one by one. First question is like, will it work with things with the extension? I can't say with confidence that it's absolutely work, but from my usage experience, I think it works. Double check with the documentation. The second question is that, sorry, can you repeat? I don't have good memory.
Can I set a threshold for maximum?
Oh, yeah. The second question is like, can you set a threshold to this? Again, I can't say it with confidence because I don't have like, I'm not the creator of this, so I won't take the credit. So I can't remember all the nooks and crannies of it. But from what I remember, you can't set a threshold of like, oh, I need to get a warning or something when it over certain memory. So I don't think so. Okay, but double check. Don't take my word for it. Yeah.
Thank you.